All right, I'm going to introduce a couple of really good friends of mine. I'm super excited to have them up on stage here. I'm really excited to watch what they showcase. We're going to be joined by 4IR, TwinThread, and LSI. So I'm going to start with LSI. Logan has nearly 15 years of experience in industrial automation and digital transformation, leading enterprise scale initiatives that deliver measurable results for manufacturers. And over the past 6 years, he has helped build and lead high-performing teams focused on Industry 4.0 concepts. At LSI, he co-directs the digital transformation practice, helping his clients move beyond dashboards and pilots to scalable, value-driven transformation by aligning leadership, workforce, process, and technology. From TwinThread, Virag is a technical solutions engineer where he specializes in helping manufacturers bridge the gap between massive industrial data sets and operational insights. With a background in chemical engineering and process automation, Virag has been able to leverage his integration experience into the next wave of technology deployments to support manufacturers in critical work that they do. From human-centric solution developments to ML-based optimization, he is always focused on driving advancements for an industry long underserved. And last, and certainly most least, because he is indeed a Canadian hockey fan, James is the CEO and co-founder of 4IR Solutions, a technology-enabled OT managed service provider, helping industrial enterprises design, deploy, and operate modern OT platforms at scale. Through their flagship product, Factory Stack, 4IR delivers standardized, secure OT infrastructure and operational services that simplify complex IT/OT environments and support long-term digital transformation across enterprise operations. James works closely with customers, partners to cut through the marketing noise, focus on what actually runs in production, and ensure solutions deliver measurable, production-ready outcomes. Please join me in welcoming them shortly to the stage after their video.
How do you successfully turn data that is often lacking structure and context into value? How do you use technology to drive the right behavior and actions across your enterprise? You find the right partners, define the right strategy, and select the right technology. The right team solves problems faster, smarter, and at larger scale. Let's meet your partners. Logical Systems, LSI. LSI is a global full-stack integrator built around three main pillars: automation and controls, process and mechanical, and digital transformation. With over 375 resources, they have the expertise to support you however needed. Listen, strategize, architect, build, deploy, adopt, and optimize. This is the LSI way. 4IR Solutions. 4IR breaks down barriers to deploying complex, multi-site industrial architectures and accelerates the deployment of enterprise-grade OEE, MES, and SCADA with Day 2 support from the start. Their growing catalog of supported software allows their partners to pick what they need, select where it is installed, and allow Factory Stack to manage it all, covering everything from updates through identity management. TwinThread. TwinThread's complete platform is designed to empower teams, operationalize insights, and connect industrial data ops, AI, and BI. Purpose-built by experts, their pre-built industrial AI solutions tackle nearly every use case. Through hundreds of global deployments, TwinThread is proven to help run operations more effectively, with less downtime and better results at scale. Think big, start small, and move fast with TwinThread. The LSI-designed architecture securely connects data from the edge to the cloud. Scalable, fully managed enterprise infrastructure from 4IR provides the foundation, while TwinThread's industrial AI platform transforms data into actionable operational insights, creating net new information, driving smarter decisions, and delivering real business value. 55 vendors. One data set. ProveIt. Here are today's presenters. From LSI, Logan Terry, Co-Director of Digital Transformation. From 4IR, James Burnand, CEO. And from TwinThread, Virag Vora, Technical Solutions Engineer.
All right. Thank you, everyone, for coming to see our session today. You know, when I woke up this morning, I thought the most stressful part of my day would have been this presentation, and then I watched the Canada-Czechia game. Thank God we pulled off the win. So we will see you in the gold medal game, Remus. But today we're going to talk about something really practical. We're not going to talk about hype, we're not going to talk about theory, and we're certainly not going to talk about how AI is going to solve all of our problems. Today we're going to walk through how you actually move from dashboards to decisions. Let's jump in. So the first thing we're showing here is a typical area level roll-up report. This is looking at Enterprise B, the filler production area at Site 1. We have 3 lines underneath of it. We get our area summary, including OEE, availability, performance, quality. We get our production roll-up report, including all 3 lines rolled up into one set of values. We get our top downtime reasons, and we get area alerts with criticality associated with it. We also get these prescriptive area recommendations shown at the bottom. As we continue through the report, we see our drill down into filling line 1, where we get a lot of the same information, but we start to add things like mean time between failure and mean time to resolution and our failure count. We go further, we get our unplanned downtime breakdown, our hourly breakdown for that shift for the specific assets. So for filling line 1, we see our hourly breakdown. We get performance details. We get our line level alerts with criticality and our line level recommendations. This level of detail drastically improves shift handover. It improves accountability, and it improves root cause assessment. This is the level of detail in reporting that most teams strive for, but often fall short due to technical barriers and resource constraints. But imagine a world where you don't have to chase people on the plant floor down to gather the data for these reports. You don't have to work with your teams to determine the bad actors, and you don't need to schedule meetings to determine the recommendations. The shift finishes, the report is generated, the prescriptive actions provided. Now all your team has to do is act. That's the promise of cognitive analytics. Some will say that generative AI isn't quite ready yet for this type of implementation, and they wouldn't be wrong. It's not really in most cases. But if you build less deterministic tools like Gen AI on top of more deterministic data and context foundation, it changes the game. But to understand how we get there, we need to take a couple steps back. So what I'm going to show here is the analytics maturity curve. Every organization that's in this room right now sits on this curve somewhere. The stages are foundational, your data, you know what data you have and where it is. Descriptive, your data tells you what happened. Diagnostic, you start to understand why it happened. Predictive, your tools maybe allow you to determine what is likely to happen. And prescriptive, you start to be able to influence outcomes. Then you get into cognitive. That's the autonomous inference layer that sits on top of everything. It summarizes, it reasons through the information provided by the deterministic layers below. Now, just by a quick show of hands, who would find their analytics maturity in the foundational stage? What about descriptive? What about diagnostic? Predictive, prescriptive? Who's made it to cognitive? Nobody. Okay, we'll continue on. Of course, you don't move your entire enterprise through each of these stages all at once. You focus on use case by use case, focused on fast time to value efforts and additive progress. A lot of people I talk to want to go straight to the end. But to everyone in this room, and especially those eager folks, investing time and money into those earlier, less glamorous stages is not pointless. That's what builds the deterministic foundation that cognitive systems need to provide the value that they promise. But this progress isn't always easy. So let's take a look at some of the common challenges that people face in each of these stages. When you look at foundational, things like connectivity and accessibility become challenges. In descriptive, you could have poor UI UX designs that cause manual inference challenges. In diagnostic, your data silos and your tribal knowledge problems become barriers to progress. In predictive, your one-off models reduce the value or ROI, could be very complex and costly. Into prescriptive, you start having trust and change management challenges. And ultimately in cognitive, your lack of context is going to reduce the value that the systems are able to provide. Scalability and determinism are challenging, and security is king. So let's see how we overcame these challenges. Take a look at our architecture real quick again here. We have 3 enterprises connected to our system, but for today we're going to focus on enterprise B and C. 4IR provided cloud infrastructure via factory stack. HiveMQ broker as our central broker. We added Ignition 8.3 as our central applications layer. And we had Postgres as our time series and relational DB. Those pieces provided the descriptive and diagnostic foundation for our application. Then we added TwinThread. TwinThread provides centerlining, optimization, and anomaly detection. That adds the predictive and prescriptive component. Finally, we added in Neo4j and N8N. That adds deterministic tool calls, context graphs, and agentic workflows. That adds the cognitive piece. But cognitive analytics is not just a chatbot, it's an architecture. So let's take a look at what we built on ours. So I'm gonna drill into our first demo here, pop over on this screen. First demo we're gonna pop up here is an Ignition 8.3 application that was built for Enterprise C. This is 0.3 Therapeutics, Biopharma, 4-unit batch train. We have our single-use mixer, our bioreactor, our chromatography skid, and our filtration skid. In here we see progress through the current phase, the expected completion time. We see our key critical snapshot for our process values, spark lines showing value over time, our upper and lower control limits. We can even drill in and see historical data over time. As we go into the sub 250, we get a traditional P&ID view here where we can see the state of all of our devices, HOA pop-ups, etc. This provides situational awareness, and it's probably where most typical SCADAs are. But if we go back to the command center here, where most SCADAs don't have is this one single value here, this TwinThread anomaly score. So we trained TwinThread on all of the previous good batches that we had access to, and what this score does is tell us how anomalous we are compared to our perfect batch. That data is fed back through the HiveMQ broker and visualized in Ignition. But to talk about all the work that goes in behind on the TwinThread side, I'm gonna pass it over to Virag.
Awesome, thank you, Logan. So as Logan mentioned, one of the big challenges in Enterprise C in this year's virtual factory was being able to actually access complete batches. So for any of the other vendors out there, you understand the challenge that I'm talking about. A lot of times, there were partial batches that were being ingested or recorded. There were interruptions in batches and so on and so forth. In the active batch, what we're actually able to do with the models that we build in TwinThread with a solution template such as Perfect Batch is actually compare the current phase, the current operation, with what the ideal profile is supposed to look like based off of quality attributes either associated with yield or pH or if you have any other characteristics. In this case, because the virtual factory didn't provide it, we basically assumed some of the statistics associated with the timing of those batches. And as Logan mentioned, right now, the score indicates that we do have an active anomaly. And we could see that in this case, the flow control valve is stuck open for some reason, right? So it's being flagged as an anomaly. And ultimately, multiple occurrences of similar or different anomalies, both related to process, to timing, to material consumption, results in this overall process score and timing score on the batch. And if we look back, if we look back 3 months over the course of the entire duration that we've been able to capture any of the data from the virtual factory, we can see that we've had a variety of batches, some good, some bad, as judged by adherence to the golden batch profile. We'll see how we configure this a little bit later in the centerline model. But for now, we're going to continue the story as we showcase Enterprise B and what we built for that use case.
Awesome, thanks Virag. So I'm going to jump back over here and show our demo that we built for Enterprise B. So Enterprise B was a 3-site beverage manufacturing company. Each site has multiple areas. Each area has multiple assets or lines underneath. So we can see here, right now I'm looking at site 1, filler production area. I'm looking at the previous shift with an interval type of hourly, and I'm filtering this by group by lines. So this is a typical scorecard view. It shows us, our availability, performance, quality, and calculated OEE over that previous shift. Green, yellow, red kind of indicates how well we're doing, but it doesn't really tell us anything about, why we're doing poorly or anything like that. We also don't understand what good is here. So I'll continue to enrich this with some additional context. So I've enabled targets here, really, really simple addition, but at least this gives some indication to the people that you're working with. Maybe you throw this up on a big screen over your production floor to allow your operators to know how they're performing. At least they know where good is. They don't just see some colors. If we continue to enrich this, let's say I expand filling line 3 here, obviously availability is a bit of a problem. I'll expand this and see my state timeline. So for that previous shift, now I can see clearly at what times I spent in what states. So I can see, between cleaning and unplanned and planned downtime, obviously my availability is continuing to decrease. I'll continue to enrich this further. I'll enable some trends. This will load up here. It's pulling in all the data right now. So once that snaps in, now we see an hour by hour value or calculated value for availability, performance, and quality. That continues to provide descriptive depth into this. But it still doesn't tell us a lot about why or what's going on underneath the hood. So we open up our details pane here. What this is doing is totalizing the time spent in each state for every hour within this period. So we can see how long we were running or down in each of these intervals. Further drill into the downtime where we get our downtime reason Pareto. I can drill further into that and say I want to look by unplanned downtime. So now I get my downtime codes and which ones are causing the most downtime for that given shift. I can further drill into reliability and see my state timeline filtered by unplanned downtime events. From that, I can calculate things like mean time between failure and mean time to resolution. I also get a tabular view of all of the downtime events and their associated codes and durations. Now we drill into performance. Here, what we can kind of see here, it's performing very well right now, but the gray area represents our capacity to produce based on the design rate of the equipment. The green area represents how much we actually produced for each interval. So where there's a gap, we can see we have slightly lower performance here. To see this in a slightly different way though, we calculate an average unit per minute rate achieved per hour and compare that against the standard or the design rate. So the gray area here represents our rate loss. If we were far enough below the target rate, we would animate yellow. If it was far, far below, we would animate red. The next piece that we show here is quality, so good parts versus reject parts totalized per interval within the period, and then our calculated quality value. Then we bring that all together for each interval and show each of the 3 metrics and the calculated OEE. So as we all know by mathematics, OEE, if you have a 10% increase in one metric and a 10% decrease in another, you have the same OEE, but you're operating in 2 very different scenarios. So it's very important to focus on the 3 individual metrics, not just the outcome of OEE. Now, jumping back here, looking at all 3 of these lines, it's pretty clear that availability is the biggest driver for reduced OEE. And we're pretty confident that with the diagnostic and descriptive tools that we've provided here, this manufacturer could probably chew away with their continuous improvement team at that gap. What we want to focus on though, if we look at filling line 1, this 97.5% quality, it looks good, but over this shift, we produced a total of 113,000 parts, but only 110,000 were good. It's 3,000 rejects in a single shift. That's a lot of scrap, that's a lot of potential rework that can cause material and labor variance that erodes profitability for a manufacturer. Closing that gap of 2.5% is often the hardest, where you need additional tools to help you understand what's causing higher or lower amounts of rejects. So I'm gonna walk through a bit of a scenario here. I'm gonna open up our process data tab here, and this is gonna load the last 2 hours for a given tag. Let me make sure my network is up here. Interesting. Try another one. Okay, well, oh yeah, it was a network blip.
You guys asked for live demos? Did you get live demos?
Live demo. Faulty network and all. There we go, we're back. All right, so we see fill pressure and fill temperature here. What we can see, the blue line represents the PV for the associated value we're looking at. The orange dotted line represents our set point. We can see that set point's bouncing around quite a bit. And that could potentially be because you have a changeover where you have an automatic recipe change for the SKU you're running. It could also indicate that an operator has been moving that up and down, trying to improve the performance on the filler. Regardless of what is changing that, it's really hard to understand how that impacts our ultimate OEE metrics. And that's only for 2 PVs. Now you extrapolate that to 20 or maybe 200, and the human brain just can't infer or comprehend that much information to determine how that's impacting the actual performance. The other thing we see up here is a recommended set point that we're displaying of 26.4 PSI for the fill pressure and 37.9 degrees Celsius for the fill temperature. We're gonna let Virag talk a little about how those are derived and the perfect centerlining tool within the TwinThread platform.
Yeah, thanks, Logan. So this was actually a pretty fun scenario that we were all able to jointly work on together. So Enterprise B, as Logan walked through, it had a lot of the metrics, so it had the high level OEE, availability, quality, et cetera. What it didn't have as much of was the raw process data. So what Logan and the LSI team did was actually build their own simulation within the simulation, basically, using a variety of different complex methodologies, derive a relationship between a degrading defect count, so higher defects in certain conditions, the further you are away from what they defined as a ideal target or your center lines. And so what we ended up doing in TwinThread, we deployed what we call our perfect centerline solution. And a lot of you out there know what centerlining is, but just in case, it's a technique that we use very often in the industry. It's kind of a starting point to reduce the amount of variability that you experience. It's looking at your historical data and determining what your sweet spot is, right? And sometimes you're gonna wanna work on ideally developing those for startup conditions, for changeovers, to avoid the amount of loss that you experience during those flux conditions. And so on the TwinThread side, we ended up plugging in the data that we were able to ingest both from the virtual factory and then also what Logan and his team developed. And we deployed and trained a model against what those runs have told. And the center lines that these models came up with ended up, in this case for the orange soda segment, within 0.1. And then for the cola segment, right on target in terms of what they identified in their algorithm. And to give you a little bit of an understanding what model configuration looks like in TwinThread, this is very similar to what you would see in the perfect batch side, but the goal is to enable somebody who isn't necessarily as proficient in data science or as fundamentally trained in the data science best practices, give them a tool set where if they're a domain expert, process engineers, reliability engineers, they can work through these wizards and end up with a trained functional output solution with the model dealing with all of the feature optimization, filtering, evaluation, data set considerations automatically. And so that was a critical element for us to be able to merge the data sets both from the virtual factory and what we were able to find through the data sets provided in the exercise. Similar to what you've seen with the perfect batch and perfect centerline applications, we actually at TwinThread believe that templates are going to be the great value accelerators, both in time to value, energy to value, resource constrained situations. So all of these different templates resemble use cases that we've seen often requiring machine learning and AI in the industry. And so the same workflow that you saw with the two models that you've seen, Enterprise B and C, is what you would go through to deploy any of these other solution templates. And now to cap off the analytics journey that we've talked about, I'm going to welcome back Logan to give us our finale, if you will.
Thanks, Virag. So Virag walked us through how TwinThread adds predictive and prescriptive components to this application, but we haven't talked about cognitive yet. So what I'm going to do here is open up this sidebar, which is actually our LSI assistant chatbot that's built into this application. This, you'll notice we pass in context, so we're passing in where the user is currently navigated to within the application. We're looking at the 3 filling lines, and we're passing in a time range that they're currently looking at, which is the previous shift that runs from midnight to 8 a.m. I'm just going to submit a simple prompt here, compare these assets. While that's running, I'm going to jump over and give you guys a sneak peek under the hood at what's happening here in the background. So what I'm showing here is the agentic workflow that we have configured here. Let me get rid of that. I'll jump over to the editor. So we can see our agent webhook first that's being called from Ignition. We have our agent. The agent's connected to a number of different tools. So we have Postgres tools for pulling relational data and historical data. We also have tools directly into Ignition's web dev module to fetch the data the same way that it's being displayed on the screens. And we have tool calls into Neo4j, which is a graph database. It's a database that we're using to store context about the facilities. So what assets feed which assets, what data points are associated with which assets, et cetera. So from there, I'm actually going to jump over to our context builder here. First thing I'm going to show is the knowledge graph that was created in here. And this only shows the kind of the parent-child relationship, which is only part of the story. As we drill into Site 1's filler production area, filling line 1, we can start to see the historical data points that are available there. But if I drill back into this here, I'm also going to look at Site 1's process flow. So here we've created this node editor where we can drag and drop nodes, the assets, and select what type of relationship they have to each other. So this determines and sets the context in Neo4j for how the assets actually feed one another and how product moves through the facility. Let's jump back to our application here and see what this has come back with. So I said compare these assets. First thing it's doing is an executive comparison, so ranking the OEE. It's giving me a side-by-side of the underlying metrics, so availability, performance, and quality for each of the lines. It's telling me what's driving the gap. It's seeing some key points for filling line 3, and it's giving me some actions. And this is really where the value is. This application of this chatbot's not designed to create net new information for the user, but it's designed to accelerate the time it takes to get to insight from an application, like a dashboarding application. The other thing I'll note, I'm going to submit another one. Show me the unplanned downtime breakdown for line 1. The tools in the background, it's designed, the workflow is contextualized, and the system prompt is designed such that if you submit a common query, something that is available through the OEE application, it's going to use the same data pulls that the OEE application is using to visualize that. That allows the user to verify the response from the chatbot against the dashboard, but it allows them to get to the insights quite fast. The other thing is if they submit a prompt that's not common within the OEE application, it does have tools to get a little bit more flexible, but with LLMs, more flexibility means less determinism, which is often a problem. So here we can see it's pulled down the downtime codes, it's plotting a Pareto. I can export these directly from chat. I can export the CSV from chat as well. It's pretty powerful stuff. The other thing I'll note is that report we were looking at earlier, that's actually generated and sent out automatically by a slightly similar or slightly different workflow that we have configured. That workflow pulls the same data programmatically scheduled at the end of each shift for each asset, provides a summary, provides the prescriptive actions, and then emails it to the people that they need. So I'm getting those constantly every 8 hours for all the assets. That's pretty powerful stuff, and that's cognitive analytics. All right, but none of this works without reliable and secure infrastructure to build these applications on, so I'm going to pass it over to my friend James to talk a little bit further about that.
Awesome. The most exciting part, the architecture, at least for me.
There you go.
All right. So there's two things I want to cover off today as we talk about architecture. So really the first thing is we want to talk about what is a production grade system, give you a little description as to how that differs from what you see on the screen, a prototype. And then we really want to talk about how in this scenario that Logan and Virag showed, we could use these composable architectures and the factory stack system to be able to scale this system out across an entire enterprise. So behind me you'll see a wonderful little factory stack bridge, and on the left we talk about prototypes. So this is famously on the Ignition website, it's the 0 to 3 minutes. It's get it working on a VM on my machine. I run some Docker containers. I use the tools and capabilities that are available to me to be able to develop fast, to build prototypes, and to do proof of concepts. Those aren't production systems. On the right, we're really talking about production systems that include a whole lot more complexity, and that's both technical complexity in terms of things like IT standards and multi-factor authentication and TLS and SSL certificates, as well as security scanning and regulations for the industry that you may be in, as well as operational processes. So things like monitoring and alerting and change management and incident response procedures, those are all critically important when you're running these things at scale. So one of the key parts of that production grade system is observability. So observability lets you observe, report, and react to situations. So we use a combination of IT tooling and automation to be able to capture information about the deployments that we have. That's applications and MQTT brokers and hardware and log files from Ignition. And then we've built a set of alerts and alarms and dispatching that lets us react to those things. So most of our customers find out about something that happened after we've repaired it. And hopefully that's before there's any sort of degradation in system use. So you might be thinking, oh, that's cool, but why do I care? Why does it matter to me? Things like Kubernetes and composable architectures that inductive automation did a fantastic job of presenting yesterday, those things are complicated. What does it actually get me? So we decided to use an example. So this is a different view of the same architecture that Logan showed earlier, but what it shows here is on the left, you'll see the 4IR management stack. In the middle, you'll see the 4IR applications. And at the top, there's some external connections that we're using to talk to other services, like the ProveIt broker and like TwinThread. So if you imagine this application gets deployed, and all of a sudden it becomes popular, and you say, hey, all of a sudden I have a couple hundred users, and this architecture is no longer suitable to be able to provide that. I start to need a scaled out architecture from Ignition. I start to need high availability brokers, and I start to need database clusters that are larger in scale. So for us, we just add them. We add the additional services, we update the load balancers, we change the ingress controllers, and we fundamentally change nothing about the architecture to make that scale out architecture available. So the next step, hey, I got a bunch of plants maybe in the US, and it would really be great for some of the latency sensitive parts of that I really need to deploy those things on-prem, and I maybe need some databases down there, but my plants aren't all the same. Some of my plants have sophisticated support capabilities and highly capable engineers, and some of them don't have that luxury. So we can do that too. You are able to deploy, and I show 3 plants on here. You can't really read it, but the one on the right says Site X because this could be 50 or 100 or 200 locations. It really doesn't matter. The architecture is completely scalable. So now you might be thinking, well, that's cool if I'm in a single region or I'm supplying something across a single country or an area, but what if my European counterparts decide that that would be something really awesome for them as well? So one of the architecture and design principles that we believe in is you probably shouldn't cross an ocean to look at a web page. I know it sounds crazy. So to be able to service that, what we do is we actually duplicate that architecture in another region, and then we stitch all the data together using enterprise brokers. So as you can see, we changed nothing from the base architecture to go all the way to something that would cover the largest of enterprises. So that is what is behind this demo today. We, obviously the very first one, not this, but hopefully you guys find that useful.
Awesome. Thanks, James. And thank you for providing the infrastructure for our application. It was rock solid from the very start.
Awesome.
But we got to answer 4 important questions here. So the first important question is, what problem did we solve? Well, the manufacturers that we work with had data, but they lacked analytical tools to provide operational insight and make accurate data-driven decisions. Enterprise C in specific lacked the tools to predict batch quality, and Enterprise B lacked the tools for proper continuous improvement programs. How did we solve it? Well, in collaboration between the 3 companies here, we applied strong industrial data ops practices, we built contextualized applications, and we operationalized ML and AI and moved from dashboards to decisions at a large scale, all built on secure cloud infrastructure that we stood up in days rather than months. But how long does this take? So let's go into it. Enterprise OEE application for Enterprise B. It was 100 hours of Ignition development, 16 hours of TwinThread modeling, and 24 hours for the agentic workflow development. For Enterprise C, for the batch intelligence application, that was 40 hours of Ignition development and 24 hours of TwinThread modeling. And on the 4IR architecture side, 32 hours of provisioning for that entire infrastructure, that architecture that was stood up. All right, last but not least, how much does it cost? So Enterprise OE application based on labor hours was $25,500. Batch intelligence application was $12,800. The architecture from factory stack is $32,000 per year for fully managed. The Ignition licensing for this, $22,000, just under $22,000, or free on the 2-hour trial if you wanted to do a proof of value, proof of concept. The TwinThread licensing monthly cost for Enterprise B was $645. For Enterprise C, it was $1,455. That brings our grand total year 1 cost to about $117,000 for both applications combined. So that's all we have for today for our demo, but we do have a workshop starting at 4:30 in room H. This QR code would take you to the registration page if you guys want to join. We'd love to see you there and drill down a little bit deeper into this. Thank you all for being here. Thank you for listening to our presentation, and I hope it was insightful.
All right. Really great job, guys. That was awesome to see. As has been in most sessions, you see the Slido code up on the screens, so please go ahead and scan that QR code and start entering your questions. They'll pop up here. I'll read some good ones, and we'll get some good answers. I'll start with one, though. It's kind of been a theme throughout this whole entire ProveIt is around AI and agents, right? So as we deploy these agents in AI, how do we validate that the results that they're giving us are actually valid and make sense in the real world of production?
Yeah. I mean, that's a really good question, and it's, as I've been playing and building out more agentic workflows, the validation piece is often the hardest piece. They're doing very complex tasks, and often you don't have a good foundation to vet that against, right? That's the exact reason that we went with the architecture we did, and the way we integrated this agentic workflow with the Ignition data. We had the agent pull data through the web dev module of Ignition, so it's pulling the data the same way and returning it in the same format that is displayed on the screens, including some of the structure for how the graphs are visualized, so it knows how to create those visuals in the response. That allows the user to actually pull up the dashboard location in the screen if they think there's something odd or invalid, and they can compare against what they see in the deterministic dashboard application. So that's the method we chose there, and I would highly suggest that if you're not validating and verifying the output of your agents, please do, because they do like to hallucinate often.
Yeah, and I would say similarly from the modeling side, what we did in TwinThread for the batch models and the centerline models, we were constantly using the newly ingested data from the virtual factories to identify, are there any changes in the coefficient of determination? Are there any changes in the error rate? So trying to push even machine learning closer to determinism as possible, even though that's always going to be impossible in scenarios where the broker goes down for 3 hours and obviously there's a blank period of time. So working through as best we can with that.
Awesome. So anybody that knows me knows how much I harp on business value of these types of investments. So how much value do you think was driven by this to justify the investment there?
Yeah, so in my experience, typically an organization will get between 3 and a 5% OEE bump just based on increased situational awareness. Then you start to add in the diagnostic tools that they were provided to start running CI programs around the reduced OEE, and then the TwinThread component for closing that last gap of the 2.5% quality, right? Even if you're never going to get the whole 2.5%, but let's say you close that to 1%. So 1.5% of your total production you've then removed as far as scrap and rework. So for this organization, that's 1.5%. In that situation we saw, that would equate to about 2,500 rejects saved per shift, per line, across the entire enterprise. I would say just based on that 1.5% increase alone, you'd pay for this solution multiple times over.
Awesome. This one I think we'll probably go to James. What cybersecurity standards do you conform to, and how do you support data sovereignty requirements for regulated, specifically pharma and critical infrastructure?
Sure. So we follow the best practices guides for both AWS, in which we have our solutions been reviewed, as well as in Azure. We follow their best practices. We use the Ignition hardening guide for any of the Ignition deployments. And we're almost on our SOC 2. That covers off kind of the IT-centric part of it, but the regulatory and data sovereignty and that typically for customers that have heavy regulation. So we work in defense, we work in nuclear. For those folks, we typically will deploy inside of their tenant. That allows for their perimeter of controls and security and management to still be in place, but we can operate those resources on behalf of those customers. So we still use the same deployment pipelines. We work through the security models and the shared responsibility model, because different people pay the bill for Azure and AWS in those scenarios. But that's all part of building out that architecture with the customer.
Yeah, and keep it on the same question with James. I guess we'll go to the next one. Why would somebody go with a pre-built suite versus building it with a partner?
So acceleration, time to value, certainly having the experience of someone that's been through the bumps and lumps and knowing what to do to make things effective. I think this also maybe applies to you guys as well.
Yeah, I kind of wanted to ask maybe a follow-up to whoever asked that question. Was there a specific part of the application that you're referring to as far as pre-built? And
Potentially TwinThread.
maybe before you answer, I'll talk about my component, and then I'll let you talk about the TwinThread component, or LSI's component. So the Ignition infrastructure, the Ignition applications that we built are just built on Ignition, which we all know is highly customizable. So what we built here is just one way that we thought would be good to show for this session on how you can visualize OE and what type of tools you can implement for diagnostic and descriptive analytics. If you wanted it different, if you do it different, if you want to visualize different, this is just a starting point. The analytics behind it are probably the more important thing than how it's laid out, and that is what is going to really accelerate time to value, is having that analytics methodology pre-configured.
Yeah, I mean, echoing basically the same sentiment. It looks slightly different in the world of machine learning, but ideally, solution templates give you a grounding force through which you can scale very quickly. We've had customers start with proof of values and very quickly want to deploy a centerline model from one paper machine to 60, right? And having to build that over and over again from site to site versus using that same solution template, using that same class, and then basically just rewiring the signals that lead to those properties makes a big difference, both in terms of execution and governance. You don't want all these slight variations to those centerline models if you're going to codify those as law as far as process book conditions go at your organization.
Yeah, I think this one is a good one based off of your slides, Logan. Based on your maturity curve, what would you say would be the best place to start for someone right now that has no analytics?
Yeah, I highly doubt you have no analytics, because seeing data on a screen is a form of analytics. That's descriptive analytics in its simplest form. So as you follow that curve throughout, right, I would suggest on a use case basis, you move progressively through each of the stages. So regardless of where you are, if it's descriptive or diagnostic, you start stepping through that and seeing the value that that's providing. The value that it provides will start to indicate how much value there is in moving to the next step and how much better you can get on that single use case. If the ROI isn't there to move to the next stepping stone, then you move to another use case and start progressing things until you are at that last 2 or 3% that you're closing off with complex tooling that you need to do so. So I would say, to maybe concisely answer your question, is if you're not already doing, some nice visuals, dashboarding that gives situational awareness, or historizing and doing some mild analytics, even just out of SQL for what you're doing there, that's the place you want to start. If you're way beyond that, you want to start obviously with the next stepping stone.
Yeah, this one's a little interesting, a bit of a question here, so I'm going to reword the one that's there a bit to say, so obviously you guys are 3 different companies here. As you look at maybe potentially helping customers solve these problems, are pieces of the stack, let's say, swappable with other technologies? Let's say a customer doesn't want to use TwinThread, for example. They have their own analytics platform, or they want to use something other than Ignition, or something other than 4IRs. Talk about a little bit how this might be swappable with different parts of all the cool partners that we've seen here today.
Yeah, if you guys are okay, I'll take that one.
Leave the 4IR part. It's good.
Yeah, so everything in here is kind of modularly put together, right? So Ignition is the SCADA we chose. It's also running because it has a powerful Python scripting engine. So we're running some of the analytics in there. But you could just as easily swap that out with, WinCC OA or Tatsoft, right? You can swap those out if you want. This is one way of deploying an application like this. There's 1,000 ways to do it. Depending on where you're at with your tech stack, where you're going with your tech stack, what your architecture is, that's what a partner like LSI comes in, to really help, is to drive those architectural and technology selection questions that you might have.
Yeah.
And if I could just add to it, is the choice of technology sometimes makes a big difference in the project and sometimes it doesn't. Having a set of tooling that is from a collection of people that often work together. So when you have tools from vendors that have pre-built integrations or designs or templates or even support that stitches things together, that can make the experience easier for you from a support perspective and from a management perspective. But it's not a requirement. Whatever tools work best for your particular situation. I happen to think the 3 of us together make a pretty nifty demo, and certainly the tools I think are pretty compelling the way they're stitched together. But yeah, there's always other ways to do things.
Right. Yeah, and because it's on there too, like in the Veeva side, advanced analytics is a great comparison tool. It is TwinThread. We have a partnership agreement with Veeva, so you see a lot of similarities there. The main difference that we deployed in this case, we used edge connectivity, so we wanted to get down directly to the data source instead of through Connect. So depending on what your stack looks like, if you're using a Veeva Connect, you can layer very easily on top of that advanced analytics. In this case, we used a variety of other data sources, so it's going to be. I don't think that's really the concern. It's like the pieces are going to be the important part.
Okay, we only have about 1:30 left, so I'm going to finish with my final question. Is if you had to leave one thought in the mind of everybody that's walking out of this room for the E3 of you, what would it be?
I'll go first.
That's a deep question.
Don't forget about day 2, because it is, as you look at some of the things that you've seen this week and worrying about how do I configure, how do I set up for the first time, and how do I get it to work, that's part of it, but you also have to live with that for some period of time, and really making sure that whether you use a managed service or whether you do it yourself, or you have your internal IT group or internal OT group do it, just make sure you've thought through how you're going to update and manage and grow that basis of whatever it is that you put out there.
Maybe what I would respond with is, that the old adage where you shoot for the moon, at least if you miss, you'll hit the clouds sort of thing. In this case, when you're progressing through the analytics maturity curve, it's not always good to shoot for end state, right? Because you can miss a lot of the foundational material that you need for the end state to actually be as valuable as it's supposed to be. So I would say, be realistic about your strategy. Define your strategy in a way that every step it gets, progressively, it's additive value, additive effort as you're moving through it. But make sure those steps are aligned in the right direction, right? Make sure you have your end vision in mind so that you're making these additive or, small baby steps towards that, but they're all heading in the right direction.
Yeah. and I'll keep mine short, I would say solution templates or pre-built solutions are often viewed as constraints. I think of them as catalysts. So, depending on the needs that you have for use cases, you want to be able to find whatever solution is going to give you that catalyst to get those outcomes as fast as possible.
All right, give me a round of applause to thank our ProveIt sponsors and vendors. And that's it for this session.